Now we're going to take these 2D shapes we've been looking at and rotate them around either the X or the Y axis or one of their sides to make a 3D shape. So some of the 2D shapes that we'll be rotating are going to be triangles, rectangles or squares, and hemispheres. And whenever we rotate them, we're going to get different 3D shapes. So if I take a triangle, we'll have a right triangle here, and I rotate it maybe along this side down here. So I'm going to rotate it along the bottom side. All right, if you imagine this spinning around, I'm going to end up with this cone shape. All right, every time I spin a triangle, I'm going to end up with a cone. It's got to be a curved shape because it's turning, it's rotating, so I can't have sides on it. But if I imagine spinning this down, it's going to give me that cone shape. Same thing as if I had turned it, rotated it on its tall side, its height. Right? If I rotate it around, I end up with this cone shape. All right, so a triangle is going to give us a cone. All right, if I take a rectangle or a square, so maybe I rotate on its bottom again. Again, it's got to be curved because it's going to be going around, so I can't have any sides and corners and stuff, so I'm going around, and it's going to end up making a cylinder. All right, so a rectangle and a square are going to give us a cylinder. And then if I take a hemisphere, which we said was half of a sphere, right, or a 2D hemisphere is just half of a circle. All right, let's say I have a hemisphere like so, and I rotate it around, it's just going to end up giving me a sphere. So those are our three options. I'm either going to take a triangle and get a cone, or a rectangle and get a cylinder, or a hemisphere and get a sphere. All right, every single time, those are how it's going to work. And we're going to use these shapes to end up finding the volume of the 3D shapes that they make. So for example, I want to find the volume of a figure formed by rotating a triangle with vertices at 0, 0, 0, 4, and 2, 0 around the x-axis. So I'm taking a triangle, and I'm rotating it on one of its sides, which means I'm going to get that cone. All right, and to find the volume of a cone, it's 1/3 pi r squared h. All right, so I'm going to first graph it. So I got my x and y axis here. I got a point at 0, 0, 0, 4, and 2, 0. So here's a triangle that I'm rotating. And I'm going to rotate it on the x-axis, which is down here. So I'm going to end up with this shape of like a cone kind of thing here. All right, which is kind of hard to see. But if I imagine that shape, right, so if I maybe redraw it over here, here's my triangle. All right, and it comes down here, and I end up with a cone. All right, the important part is to note that because I rotated it down, this height of the triangle, that's my radius. All right, and then this height, the width, kind of the base of that triangle that I originally graphed, that's the height of my cone. All right, so I can just count because it's a vertical line. So to go from 0 to 4, it's 4. So my radius is 4. And then to go from 0 to 2 is 2. So my height is 2. And now I can plug it into 1/3 pi r squared h. So I have 1/3 times pi times my radius of 4 squared times my height of 2. 4 squared is 16. 16 times 2 is 32. I can't divide 32 and 3, so I'm just going to leave it as 32 over 3 pi. And so that's the volume of the cone that's formed by rotating that triangle around the x-axis. And for another example, I want to find the volume of the figure formed by rotating a square with these vertices around the y-axis. Didn't put that on there. But we want to rotate this one around the y-axis. So a square and a rectangle are always going to give us a cylinder. And to find the volume of a cylinder, it's just base times height, or pi r squared times the height, because my base is going to be a circle. Right? So if I graph these, we've got 3, 0, 70, and 34, and 74. So here's my square, and it looks like I've got side lengths of 4. So they're all side lengths of 4. Right? Now if I rotate this one, because I'm rotating around the y-axis and it's not touching the y-axis, I'm going to end up with a hole. Okay, so if I imagine reflecting this on the other side, I end up with this shape over here. Right? And if I kind of connect them to make my 3D, I end up with the base looking like this, but then it's going to be that hole in the middle here. So this one ends up looking kind of like a toilet paper roll. Alright, so I've got this hole in the middle, so if I come draw it over here, alright, this is the shape we end up with, where this is our rectangle, or square, that we rotated, because it's not touching the y-axis, so it's going to have a hole whenever we spin it around. Right, so now to find the volume of this figure, I need to find the volume of the big cylinder and then subtract the hole, which is the volume of another small cylinder. They're both cylinders. So I'm just going to have to do volume twice. Okay, so remember, if I have at this distance here, my square is 4. So this distance is 4. And then there's another 3 from 0 to 3, 0. So that means this section, half of the middle one, is 3. And then again, the height's 4 because it's a square that we rotated around. So to find the volume of the big cylinder, I've got pi times my radius, and the radius of the big cylinder is going to be 4 plus 3, which is 7, squared times my height, which is 4. I'm going to subtract the volume of the small. The small radius is 3, and the height again is 4. So 7 squared is 49, and times 4 is 196. So we have 196 pi for the big one. And the small one, 3 squared is 9. 9 times 4 is 36. And then because they both have pi, that's kind of like terms, I can combine those. So 196 minus 136 is 160, and keep that pi in there. So my volume of just the solid part, not including the hole in the middle, is 160 pi.